Please note, this presentation is intended for educational purposes and does not replace independent professional judgment. This presentation does not discuss any past, pending, or future PAPUC proceedings. Statements of fact and opinion expressed in this presentation are those of the participants individually and are not the opinion or position of the PAPUC or its staff. While this presentation does promote compliance with existing laws and regulations, the presentation does not endorse, approve, or promote any particular program or related provider.
Hello, thank you for joining us today. My name is Krystle Sacavage, and I am legal counsel to Commissioner Ralph Yanora at the Pennsylvania Public Utility Commission. Commissioner Yanora, Shaun Sparks, who serves as Chief of Staff and Legal Counsel to the Commissioner, and I welcome you to what we believe will be an interesting and informative discussion on cross-connection control and backflow prevention. I will discuss emerging cross-connection control and backflow issues that show why these programs are critically important in the age of COVID-19 and emerging environmental contaminants such as Legionella. In the second section, Shaun Sparks will discuss the various statutes and regulations related to cross-connection control and backflow prevention and the local and state agencies responsible for these important public protection measures. Finally, Commissioner Yanora has over 40 years of experience in the water, wastewater, natural gas, and more recently, stormwater industries. He is also a licensed master plumber and a certified instructor and trainer who has been recognized by the American Society of Sanitary Engineers for his knowledge and dedication to safeguarding water systems. His field experience with cross-connection control and backflow prevention directly relate to his work on the Standards Board of the American Society of Sanitary Engineers and as a trainer for hundreds of individuals who work in the cross-connection control and backflow prevention industry every day. Again, my name is Krystle Sacavage, and today I'm going to discuss current issues with you that demonstrate why cross-connection control and backflow prevention programs are so important, especially given emerging environmental contaminants such as Legionella and the COVID-19 pandemic. Today we'll talk about three separate topic areas. First, as we know, water is the only utility that we physically ingest. Therefore, it is critically important that we protect the potable water supply from contaminants and pathogens such as Legionella. Second, the COVID-19 pandemic has highlighted concerns that the virus and other pathogens may potentially enter the potable water supply. Additionally, building closures related to COVID-19 have caused Legionella risks. Finally, recent events involving security breaches have renewed our commitment to cybersecurity awareness. First, I would like to start out by talking about Legionella and why we care about it. Legionella is a bacteria that is found in water supplies around the world. Exposure occurs when aerosol water droplets containing the bacteria are inhaled. The bacteria infects the lungs and can cause what we commonly know as Legionnaire's disease. The EPA has set detect guidelines for Legionella at 0. Control measures for Legionella include chemical treatments such as chlorine. Now let's discuss some of the recent Legionnaire's outbreaks in Pennsylvania and across the country. Between 2011 and 2012, the VA hospital in Pittsburgh, Pennsylvania experienced a serious outbreak of Legionnaire's disease that sickened more than 29 people and killed at least 6 patients. Congressional investigations revealed that the hospital did not follow proper treatment protocol and should have known about the potential for Legionella in the water supply. In 2017, Legionella was again detected in the hospital's water supply and has actually been found in VA hospitals across the country. The VA has settled many of the more than a dozen legal claims filed as a result of the outbreak. Now moving on to Flint, Michigan. We all know about Flint, Michigan because of the lead contamination catastrophe. However, most of us are not aware that the water system issues that caused lead contamination also resulted in a fatal Legionnaire's disease outbreak. Let's take a look at the timeline. In April of 2014, to save money, the city of Flint switched its water source from Lake Huron and the Detroit River to the Flint River. Flint's iron pipes began corroding immediately after this switch. In January of 2015, Detroit offered to reconnect Flint to its water system, but Flint leaders refused and insisted that the water was safe. In February of 2015, Flint signed a contract with Veolia to adopt new treatment methods. Email exchanges from Veolia show that Flint officials were aware of the lead leaching risk. In January of 2016, the former governor of Michigan finally declared a state of emergency related to the lead contamination, and the same day, federal officials began their investigation. In June of 2017, the Michigan Health and Human Services Director was charged with involuntary manslaughter for failing to alert the public of the additional Legionnaire's disease outbreak that also occurred in Flint. In March of 2015, emails showed that many of the governor's former aides were aware of the Legionnaire's disease outbreak. However, it wasn't until January of 2016 that the governor finally announced the outbreak, which was more than 18 months after it began. To date, 90 people were sickened and at least 12 people lost their lives due to the Legionnaire's disease outbreak. What caused this catastrophe? Let's take a look at the science. The Flint River is naturally high in corrosive chloride. Flint's iron pipes in its system began corroding immediately when the city switched its water source to the Flint River. The iron that was released from the corroding pipes reacted with the residual chlorine that was added to kill bacteria, making it unavailable to act as a disinfectant. Because the chlorine could not act as a disinfectant, Legionella levels spiked. When the bacteria was detected in the distribution system, water utility managers were obligated by law to increase the level of chlorine. When this did not happen, the Legionnaire's disease outbreak occurred. Based on this series of egregious events, local officials are being held accountable. In July of 2020, the Michigan Supreme Court found that Flint residents could proceed with lawsuits against the city for these decisions. In January of 2021, the governor and many of his aides were charged with various misdemeanors and felonies for these actions. Now that we understand the dangers of Legionella and Legionnaire's disease, let's take a look at the additional challenges caused by the COVID-19 pandemic. As we all know, COVID-19 has resulted in building closures across the world. Stagnant water due to these closures has created an opportunity for Legionella contamination. During closures, hot water temperatures can decrease to Legionella growth rate, which is about 77 degrees to 108 degrees Fahrenheit. Stagnant or standing water can also lead to low or undetectable levels of disinfectants, such as chlorine. These circumstances create the perfect opportunity for Legionella to grow. Based on these circumstances, the Center for Disease Control and the American Water Works Association have provided guidance regarding low-use or no-use building conditions. The Center for Disease Control has developed 8 steps to minimizing the risk of Legionella. These steps are critically important to preventing Legionella growth in low-use and no-use building conditions. These steps include developing a comprehensive water management program, ensuring your water heater is properly maintained, flushing your water system, cleaning all decorative water features such as water fountains, ensuring that hot tubs and spas are safe for use, ensuring cooling towers are clean and well maintained, ensuring safety equipment, including fire sprinkler systems, are cleaned and well maintained, and finally, maintaining your water system. The American Water Works Association has also developed advice regarding the maintenance of water systems under low-use and no-use conditions. These steps listed are imperative and must be followed in order to prevent Legionella growth. They include flushing the entire system to replace all water by using an approved chlorine testing device, creating a list of all plumbing fixtures that will need to be flushed, operating all valves in the fully open position and paying close attention to float-operated or other restrictive valves that need to be manually opened, removing all aerators before flushing, before reinstalling, replacing the aerator screens or cleaning them to get rid of scale deposits, disinfecting, heat sterilizing, or replacing shower heads, adjusting valves back to normal operating positions, returning hot water systems to normal operating temperatures, documenting all startup actions by using a daily maintenance log, testing for Legionella using an approved culture method. If there are no drinking water standards for Legionella in your area, considering using the European Union action levels for Legionella. If testing reveals widespread or high levels of Legionella in the water system, taking remedial measures may be needed. Two measures recommended by the CDC and U.S. Environmental Protection Agency include shock chlorination and thermal disinfection. Based on the CDC and AWWA guidance, the Commission, consistent with its public safety obligations under Section 1501 of the Public Utility Code, has issued a letter requesting information from Class A water utilities regarding low-use or no-use building conditions and customer outreach. Responses received indicate that most utilities are proactive and are engaging in customer outreach, especially regarding commercial customer accounts. The situation with which the CDC, AWWA, and Commission are concerned regarding low-use or no-use buildings actually occurred in a local school district located near Pittsburgh, Pennsylvania. In August of 2020, Fox Chapel Area School District announced that it had found Legionella in 4 out of the 6 of its schools. This testing occurred voluntarily by the school district because of COVID-19 closures. It's important to note that most school districts, and most businesses for that matter, do not regularly test for pathogens in the water supply, such as Legionella. Now, let's cut to the news clip covering the story.
The Fox Chapel Area School District this morning. So, Liz, they found some Legionella in the water at 4 different schools, including O'Hara Elementary, where you are. But we're told that those students are still starting that class in person today.
Yeah, that's right. Good morning, guys. So while a lot of districts are worried about COVID-19, the Fox Chapel district has a whole other problem to worry about: a bacteria, Legionella, found in the water. So there will be follow-up testing completed today. And while it will take some time for those results to come back, still, it is back to the classrooms for students. Now, according to a letter sent to families, as a precaution, water was tested in all 6 of its buildings and the field house back on August 13th. Well, this weekend, the results came back, and 4 schools, you see them on your screen, ended up having elevated levels. They are Fairview, Kerr, and O'Hara Elementary schools and the high school. So what is Legionella? Well, it's a type of bacteria that's found naturally in freshwater environments and can then grow in a building's water system if it's been dormant. The CDC reports that you can actually breathe it in, and it can lead to Legionnaire's disease, which is a serious type of pneumonia. But the district says it contacted the Allegheny Health Department and got the green light to open as scheduled. Leaders are taking numerous precautions, and at all buildings, they include heating the water to a high temp, draining the system, and then refilling and flushing it once again.
Now that we've seen all the dangers of Legionella, especially in conjunction with the COVID-19 pandemic, let's look at ways that we can prevent these types of outbreaks. Aggressive chemical treatments can actually cause piping to further break down and create an opportunity for Legionella to grow. Regular testing is necessary, but most importantly, cross-connection control and backflow prevention are crucial to protecting our water supply. These methods can prevent the reintroduction of Legionella into the water system and actually can avoid the additional costs associated with short-term and long-term treatment. Now that we've covered Legionella and COVID-19, let's look at issues emerging in the cybersecurity arena. In February of 2021, an unsuccessful attempt to poison the water occurred in the city of Oldsmar, Florida. In this situation, a hacker attempted to increase the sodium hydroxide, or lye, levels in the water supply to a potentially lethal dosage. Luckily, the plant operator noticed the intrusion on its SCADA system. This highlights the need for enhanced cybersecurity measures, especially for municipal systems in Pennsylvania and across the country. Based on this occurrence, PUC cybersecurity staff issued recommendations to utilities to prevent this situation from occurring in Pennsylvania. These steps are crucial to securing our water supply. Now let's look at a very recent backflow event occurring in McKeesport, Pennsylvania. On July 16, 2021, the Municipal Authority of Westmoreland reported a backflow incident occurring when chemical foams used by firefighters were sucked into a fire hydrant, contaminating a portion of the McKeesport water system. Test results showed that PFAS were detected in the water. It's important to note that boiling, freezing, filtering, or letting water stand does not reduce the level of PFAS in the water. As a result, the authority issued a Do Not Use advisory on July 17, 2021, originally impacting about 250 McKeesport's homes and businesses. On July 28, 2021, over 10 days later, the advisory was changed to a do not drink status. As of August 9, 2021, a do not drink advisory was still in effect for 5 homes in the area. Before I conclude, I'd like to note that sometimes backflow can occur in very unusual ways. In March of 2020, residents in a small village in Italy experienced Lambrusco flowing through their taps. Let's take a look at what happened. A silo at a local winery started leaking wine into the water pipes. The wine was shot through the water mains and directed into nearby houses. When the residents turned on their taps, wine flowed out instead of water. What happened? Wine backflow. Thank you for allowing me to discuss these current issues with you today. Now, Shaun Sparks will cover the legal requirements related to cross-connection control and backflow prevention programs. Thank you.
Thank you, Krystle. I'm Shaun Sparks. I've been working in the public utility regulatory field for about 20 years, spending about a decade at the Office of Consumer Advocate and about a decade at the Commission. So I've seen quite a bit of various regulatory filings, litigation, and regulatory activity from the Commission and at the federal level in the various work that I've done. When I started working with Commissioner Yanora, I realized I had a lot to learn. And I was surprised at how much I didn't know about backflow connection, cross-connection control, and how these two very important aspects of water service affected service that was provided to ratepayers in the Commonwealth. And I'd like to step through some of those requirements with you today so that we can learn a little bit more about the regulatory paradigm and the regulatory interaction between various state, federal, and standards agencies help protect consumers and protect the water supply. First, let's take a look at the regulatory players. We have the Environmental Protection Agency. They have the Cross-Connection Control Manual. We have the Department of Environmental Protection with their backflow prevention regulations. We have the Department of Labor and Industry with the Uniform Construction Code. We have various standards bodies like the American Society of Sanitary Engineers and the International Plumbing Code. Of course, the Public Utility Commission with its codes and regulations, and municipal and county codes. All of these interact with one another to provide cross-connection control and backflow prevention, and each has its own role in backflow prevention enforcement. So if looking at that group of regulatory players, you realize that you too might share this knowledge gap with me, don't be too hard on yourself. We're going to examine each of these in turn. Before we do that, let's take a look at Commissioner Yanora's goal, which is simple and straightforward, is the coordination and consistent application of existing laws and regulations to ensure safe, adequate, and reliable water and wastewater service. So let's jump into some details and move closer to that goal and close the understanding gap. First, let's take a look at the EPA Cross-Connection Control Manual. Examining regulations aimed at protecting the public water supply via cross-connection control and backflow prevention present a chicken and egg scenario. That is, we could build up from the manufacturing standards to the federal regulations, or likewise drill down. So don't put too much emphasis on the order of our discussion of federal, state, and local regulations. The point to take in is that this is a network of interrelated regulatory standards, all aimed in the direction of protecting the public water supply. At the federal level, we have the EPA Cross-Connection Control Manual. Chapter 6 of the EPA Manual provides for the state administration of supplier cross-connection control programs. Next, we have the International Plumbing Code, which Labor and Industry has adopted in 2015. It's published on a 3-year cycle. Specifically, sections 608.1 through 608.18 work to eliminate cross-connections and prevent backflow where cross-connections cannot be eliminated. Sections 312 312.10, 312.10.1, 312.10.2 require an annual inspection and testing of all backflow prevention devices according to the ASSE standards. Of course, the ASSE standards, that's the American Society of Sanitary Engineers. They establish the standards for protection and cross-connection control, and they get integrated into the International Plumbing Code. Moving to the state level, we have the Labor and Industry Uniform Construction Code, which was adopted throughout Pennsylvania. It requires municipalities and municipal authorities to adopt the International Plumbing Code as the minimum threshold for lateral connections to the public water supply. Next, we move to the level of municipal and county codes. Municipalities and counties enforce the Uniform Construction Code, they issue building permits, and they enforce county health codes. We can see that we enter the perfect regulatory storm when we examine how international standards bodies, the EPA, state agencies, and even local municipal officials interact to protect the public water supply. And we expect all these players to act in harmony to achieve the goal of protecting the public water supply. It's a complicated regulatory plan that reflects complicated interactions among all the public and private actors required to deliver safe water and wastewater services to the public. Over the next several slides, let's take a look at Chapter 109 of the regulations of the Department of Environmental Protection. And I'm going to break a point of etiquette in presentations and put the entire language of the regulation up on the screen. And I'll specifically call out subsection B for closer examination. I'm committing this presentation faux pas for several reasons. The first is I want to illustrate that the regulations are real. The next is that I want to illustrate that the regulations apply to suppliers and customers alike. And I want to make a point about one specific section that generates a tremendous amount of confusion for suppliers. That is the opening section of Section 109, 709B, at the direction of the department. At the direction of the department refers to the plan, not the compliance requirements of Chapter 109 all told. Cross-connection control, backflow prevention are required. That language relates to the plan alone and doesn't mean that a supplier only has to engage in backflow prevention and cross-connection control if DEP forces them to. Let's take a close look at what a backflow prevention plan might require. A description of the methods, implementation schedules, the legal authority for the program, such as by ordinance or rules, integrating with municipal requirements, time schedules, public education programs, descriptions of the methods and devices, program for review for new users, and provisions for the discontinuance of water service after reasonable notice to premises where cross connections exist. It's specific and thorough. And as we've seen, it's Commissioner Yanora's goal to have these regulations thoroughly integrated and enforced for the protection of the public water supply. And now onto my native turf, the PUC. In addition to the Public Utility Commission's general statutory mandate to provide for safe and reasonably continuous service, the Commission also plays a specific role to ensure the protection of the public water supply through Section 1501, ensuring reasonable and adequate service, tariff compliance measures, water conservation measures, water and wastewater audits, and monitoring the water supply and water delivery to ensure that there's adequate protection from emerging contaminants. While the PUC does a great more than just these 5 examples, these are pertinent to our discussion today. And not to put too fine a point on it, there is nothing new about how the PUC works to fulfill its role in cross-connection control programs via approved tariffs, which have the force and effect of law. Here we can see that the Class A water companies as a group have taken steps to protect the public water supply through tariff-based cross-connection and backflow prevention programs. When we look at those tariffs as a group, one point becomes apparent. Each company approaches backflow prevention and cross-connection control in its own way. Looking back to Commissioner Yanora's goal, Commissioner Yanora seeks coordination and consistent application of existing laws and regulations to ensure safe, adequate, and reliable water and wastewater services. One of the things that we would like to do is coordinate and provide consistency in how regulated water companies provide backflow prevention and cross-connection control. This would be an aid to the companies themselves and all the agencies involved in the enforcement of this important aspect of protecting the public water supply. Like many other issues concerning water and wastewater safety, cross-connection control and backflow prevention are familiar and long-standing examples of the PUC and DEP harmonizing their respective jurisdiction over water and wastewater service in Pennsylvania to ensure that appropriate standards are in place to protect the public water supply. Finally, let's take a look at a visual model of the regulatory paradigm that we've discussed. This example is just one way the model may be expressed. I'm sure that there are others, and perhaps better models. We'd be happy to discuss your ideas and any improvements or suggestions you may have for the Commission on this important topic. As you can see, it's complicated, and no one agency has all the enforcement power or all the regulatory authority vested in it such that it can enforce backflow prevention or cross-connection control on its own. It requires cooperation, and we'd like to ask for your cooperation as we move toward achieving this important public safety goal. The coordination and consistent application of existing laws and regulations to ensure safe, adequate, and reliable water and wastewater service. Thank you.
I am Commissioner Yanora, and as you heard from Krystle's introduction, I am going to discuss the technical aspects and equipment encountered in an effective cross-connection control and backflow prevention program. First, let's take a look at what we're trying to control with cross-connection control and backflow prevention. It's as simple as this. Water always seeks the lowest point and flows through the force of gravity, just like this. This is called siphoning. Problems occur when a hose or a pipe that may be subject to siphoning, contaminated water, is connected directly to the water supply. Let's look at issues arising when pipes subject to siphoning are connected directly to the public water supply. Problems typically occur when there is a loss of pressure on a water distribution system, such as water main break or regular maintenance. Here is an example on how such an event can occur. If there's a drop in pressure in the underground water main servicing a house, water from the contaminated source can flow back through the pipes into the house. Additionally, contaminated water from the house can also flow back into the public water system. This type of backflow event results in cross-contamination. How do you know when cross-contamination is occurring? A meter running backwards is proof of cross-contamination. This situation occurs when water is running backwards through the meter and is bringing contaminants from the building into the public water system. This situation can be prevented by installing the proper backflow prevention method. Now let's look at the ways we can prevent backflow and cross-contamination from occurring. There are two types of protection: containment level protection and isolation protection. Containment protection is when the public water system is protected at the service connection only. The water utility is responsible for this level of protection. Containment protection will ensure that backflow will not occur out into the public water distribution system. Containment protection usually means that the backflow preventer was installed just downstream of the meter. Many cross-connection control plans will only require containment protection. Isolation protection, point of use protection, is protection at each cross-connection within the building. The building owner is typically responsible for this level of protection. This means backflow protection of some kind must be installed on all cross connections that are identified after the meter. In most cases, internal protection requirements are governed by plumbing codes like the International Plumbing Code. There are 4 types of backflow prevention methods: pressure vacuum breakers, atmospheric vacuum breakers, reduced pressure principal assemblies, and double check backflow prevention assemblies. Let's examine each type. The pressure vacuum breakers provides protection against a low hazard pollutant and a high hazard contaminant. Only protects against back siphonage. Can be used under continuous pressure from the water supply. Critical installation level, 12 inches above all downstream piping. Assembly must be accessible for field inspections and maintenance. When installing in a building or structure, requires proper drainage. Atmospheric type vacuum breakers provide protection against low hazard pollutants, high hazard contaminant. Only protects against back siphonage. The device cannot be installed under continuous pressure from a water supply. Assembly must be accessible for field inspections and maintenance. No testing required. Reduced pressure principal assemblies protects against low hazard pollutant or a high hazard contaminant. Protects against back siphonage and back pressure backflow, and is the highest means of mechanical protection. Can be used under continuous pressure from the water supply. Relief valve opening must discharge through an air gap to a properly sized drain. Must be accessible for field testing and maintenance. Cannot be installed in a meter vault. Double check backflow prevention assemblies. Designed for a low hazard pollutant. Application subject to back pressure and back siphonage. Must be accessible for field testing and maintenance. These valves work similar to other backflow prevention methods we discussed. Double check detector assemblies are used on fire sprinkler systems. The detector meter is used to measure unauthorized use or a leaky fire system. Working with these assemblies requires extensive technical training and certification. The ASSE Series 5000 certification requirements include required comprehensive 40-hour training course covering industry-decided knowledge and skills, required comprehensive written exam, closed book exam, and practical exam demonstrating proper field test procedures for backflow prevention assemblies. And the certification is valid for 3 years.
Thank you for joining us. We hope that we provided you with valuable information about current events which highlight the need to protect the public water supply.
We hope that this presentation has helped you connect the dots among federal, state, and local regulations implementing this important public safety measure.
We hope that we have provided you with a better understanding of the technical aspects, equipment, and training required for effective cross-connection control and backflow prevention program.